Welcome to Science with Steph, the show where I think way too much about the world around us and then share the best bits with you guys. So this week I am making slime, which is great because it's lots of fun, I love making it, and it's a total chemistry experiment. So this is going to be fun. So to make slime you have three basic ingredients. You have PVA glue, which is any glue you can pick up for school projects and activities. You have saline solution, which is the slime activator. And then you have bicarbonate of soda, which thickens it up a little bit. Optional extras are shaving foam, which gives the slime a fluffier, more malleable texture. And then you have various food colorings, if you wish, and glitter, which is also an optional extra, but in my opinion, mandatory. So you start with the glue and you put about as much glue as you want slime. So that's probably enough. You want probably a small tub's worth. As you can see in there. About a third of that amount in shaving foam. And a very, very small splash of water. Okay, so give that a quick mix, and at this point you can add a teaspoonful, a level teaspoonful, quite a small level teaspoonful of bicarbonate of soda. Stir that in, and at this stage you can choose what kind of additions you want. I'm going to have a blue sparkly slime. So as this is not clear glue, I'm going to need quite a lot of food colouring to get that scene, and some blue glitter. Can't really have too much glitter in it, to be honest. And then off again, give that a mix. So this is the texture of what you get. It's quite thick and quite gloopy. And now for the fun part. So we want to add the slime activator. And what this does is this has boric acid in it. You have to make sure you get a saline solution that has boric acid in it. And the borate ions combine with the polyvinyl in the glue. You can already see it starting to combine there. And what they make are long, thin strands of polymers. And if you think about these strands of polymers a bit like cooked spaghetti, when you leave that cooked spaghetti overnight, it turns into a big mesh that is all entangled up and quite hard to untangle. And that's a little bit like what this slime is. And the water in the saline solution and in the little bit of water that we added fills in all the gaps in that mesh and makes the soft, slimy texture of this stuff. Now this needs less activator than you think and needs more elbow grease than you think. So it needs about 5 minutes of hard work, and you can tell it starts to come away from the sides of the bowl when it's starting to work. So what makes slime so special and what makes it fun to play with? The fun thing about slime is that it's a non-Newtonian fluid. Now that's a big fancy word for something that sometimes acts like a solid and sometimes acts like a liquid. So we always think of liquid as things like water that when you put your hand in a bowl of water, the level of the water rises. And that's because the molecules tend not to interact with each other too much. And So therefore when you push your hand in, the molecules don't squeeze together. Whereas in a slime, when you put your hand on slime or put some force onto it, the molecules, because they're so tangled up together, there's a lot of friction that happens on the inside, and they kind of bond or stick together and make almost like a solid. But then when they're not feeling any force, the whole thing acts like a very viscous liquid. And viscous is just a posh word for kind of thick and gloopy. So that needs just a slight more touch of activator. And then I think we'll be able to start taking this out of the bowl and playing with it. So, and actually slime or non-Newtonian fluids happen quite a lot in day-to-day life. Natural non-Newtonian fluid is our mucus. So anything that comes out of your nose is a slime. I wouldn't recommend playing with it too much. That's good. That's coming together quite nicely. There we go. Ah, yes. Oh, yes. So this still needs a little bit of work to get it all together in one piece. But it's starting to come together quite nicely. And the more you work this, the more the polymers tangle up and make a net to trap all the water in. So this is quite a nice slime. And the great thing about this is because it doesn't use borax, which quite a few slime recipes do. Everything in this is not harmful to skin at all, so you can play with it as much as you want. The borax, again, is the borate ions. That's what the borax is. And when you mix that in a water solution, you're mixing that in and making the exact same stuff. But because borax is used to clean things, it's actually a very, very thirsty thing, and so it draws all the moisture out of your hands, and that's why it's actually not that good for your skin when you make it into a slime. Okay, there's the slime. Pretty satisfying stuff, and then as soon as you impact it, as soon as you roll it in your hands, it becomes more solid. It's a really fun sensory thing to have, but also very scientific. As soon as I let it go, it turns into a liquid again. So here are some I made earlier. This one here is a bit of a thicker one. So that keeps its shape a lot more. But again, you can squeeze it and play with it, which is quite cool. So there we have it. Now I would caveat this recipe with 3 things. First of all, because you're using saline solution and not borax, there's a bit less active ingredient in it, and so you need more work to get it together. Now if you put too much saline solution in it, it'll become very, very rubbery and quite hard. So you want to add a little bit, mix it a lot. If it's still not coming together, add a little bit more and then keep mixing. Secondly, because these do have water in them, they will dry out, but if you keep them in a tub with a lid on, they should stay wet and slimy for about 2 weeks. And then thirdly, and most importantly, this stuff is not edible. Yes, it's fine for your skin, but make sure you're watching kids and animals when you're near it, and also make sure none of it is going down the drain, because that ends up in seas and then ends up in our fisheries. So please be environmentally conscious when you're disposing of the stuff at the end of its life. So there we have it. I hope you enjoyed this episode of Science with Steph. I bring out new videos every Friday, so if you want to watch my last one, you can click here, or I'd really hope you consider subscribing, so please click here. Alright, thanks. See you next week. Bye. I can break the walls, but I can't even figure it out.